Beginning with the polymerization. Great. What exactly polymerization is? Polymerization is a process of joining together a large number of monomers to form a polymer. The keyword over here which you need to memorize or which you need to focus on is number 1 monomers and number 2 polymer. There is a diagram over here. I hope you all can see this diagram. Can you?
Yes, miss. Yes, miss.
Great. Okay, now this diagram is kind of a metaphor of a monomer. Now what exactly monomers are represented in the diagram? They are one unit. They are single units. Some are happy, some are sad, some are shocked, but they are the single units. Now what polymerization does in their life? This polymerization connect them in a way that they became one big molecule. I repeat, these are the monomers, which are the single units. What happens to them? Polymerization happens to their life, and what is the product of polymerization is the formation of one big molecule. Now this one big molecule is called polymer, which in simple words, polymer is an Italian word which says many units. And another thing regarding polymer is another terminology which you use in chemistry is macromolecules. Polymer and macromolecules are same. It's just that simple different terminologies being used in chemistry for one same thing. What macromolecules are? They are the large molecules made up of smaller molecules. So basically there are two terminologies which you need to memorize. One, what monomers are and what polymers are. In any question so far? Is it clear?
Yes,
Okay,
miss.
great. This is something really basic.
Yes, miss.
Great. This is something really basic. Moving on to the next quickly. The other thing which we are supposed to study, that what are the types of the polymers. There are two types of polymers generally, which are called natural polymers, and the other one are called synthetic polymers. These are two polymers which we deal with. Can any one of you explain? You can just write your responses, or you can share what are natural polymers or what are synthetic polymers. How can you differentiate?
Natural polymers are naturally occurring and synthetic are man-made.
Polymers are naturally occurring and synthetic are man-made.
Excellent, very good. I'm getting quick responses. Natural are naturally occurring. Synthetic natural polymers are occurring naturally. Synthetic, great. Synthetic are man-made. Good. Very good. Good responses. So natural polymers are naturally occurring or extracted from things, and synthetic polymers are the man-mades. Great. Good going, girls. Now then, here we have a question which says differentiate between natural polymers and synthetic polymers. There are two sets over here. I hope you all can see this. One set we have protein, DNA, starch and wool, and the other set we have polyethylene, nylon, trilene and Teflon. Now my question from all of you is that which set belongs to natural polymer? My question is that
Set A.
Very good.
Set A.
Very good. Great. Awesome. That means you remember this information, and this is the knowledge which actually you need to learn. You need to learn from the lists which are given in different books like Chemistry Matters, Chemistry Prescott, Fundamental Chemistry. There you will get a list of natural polymers and synthetic polymers, and yes, your answer is correct. Bingo. Next one. The next topic is the types of polymerization. Here we have two types of polymerization generally. One which are addition polymerization, and the second one is condensation polymerization. Can you define addition polymerization? Any one of you can define addition polymerization. Now this is where addition polymerization happens. But if you need to define addition polymerization in one statement, or if I typically say state addition polymerization, then what
the
it
double
will
bond in
be?
the monomers. Miss, the breakdown of the double bond in the monomers.
Very good, excellent. What else? Okay, I'm getting some responses. Byproduct is formed in a condensation.
Polymers and no byproduct is formed.
But how does it?
Polymers and no byproduct is formed.
Okay. Okay. One statement for addition polymerization and one statement for condensation polymerization to differentiate. Hajra, yes. Hajra, you raise your hand. Hajra and Maiba lower down the hand. Hajra, you want to say something? Okay. So responses are amazing. Great. Addition polymerization is the process, repeated addition of monomers that process double or triple the bonds in the lean. Very good. In the unsaturated monomers joined together with losing an atom. Very good. Addition polymerization takes place in unsaturated compounds having okay. Amazing responses. However, I would say that when the Cambridge is asking you to state that how does addition polymerization happens, how addition polymerization, my question was how addition polymerization happens and condensation polymerization happens. So your one of the answer which I got was very correct, that addition polymerization happens with the help of breaking of double covalent bond. When double covalent bond break down, then this process is called addition polymerization, and condensation polymerization happens by the removal of a water molecule.
Yes.
Is that clear?
Yes.
Okay, so when it's been asked to state in one sentence, so your statement should be very clear and the process should be differentiated very clearly in that statement. So addition polymerization is the breaking of a double bond, while condensation polymerization happens by the removal of a water molecule. Then the story begins and it says that in what kind of molecules addition polymerization happens. So the kind of molecules in which addition polymerization happens are unsaturated monomers, and condensation polymerization happens in the saturated monomers. Now you can see a little question marks in front of unsaturated and saturated. Can you again state, I would repeat, can you again all state the difference between unsaturated and saturated hydrocarbons? Let me see who raised the hand. Yes, Arisha.
Unsaturated hydrocarbons have double covalent bond between carbon and carbon atom, whereas saturated compounds have a single covalent bond between carbon and carbon atom.
Very good, very good. Let me see the responses as well. Unstructured. Okay, let's begin. Unsaturated is double bond of carbon. Saturated does not have a double bond. Okay, unstructured. Unsaturated has double bond. Unsaturated has double bond. Saturated has single covalent bond. A lot of responses, but all are awesome and great. Yes, Asbia, you raise your hand.
Arisha, that the saturated compounds
single covalent bond in the unsaturated have carbon single covalent bond in the unsaturated have carbon double bonds.
Amazing. All of the responses are perfect. You are awesomely prepared for the International Cambridge examinations. Unsaturated are the ones in which we have double bond between two carbons, and saturated compounds are generally those which we have single covalent bond. As you are still, you have raised your hand. Is there anything you want to say? Maheba.
Miss, do we have to give an example?
Yes, good question. Very good, Maiba. A very good question. So whenever the question is, depends on the marks. If the question is coming for 3 marks, so in first mark, you can obviously tell about how the difference is by breaking of the double bond and the release of water molecule, and it's happening in unsaturated compounds, it's happening in saturated compounds. And for the third mark, yes, you can go for an example. Other than that, yes, you need to know about the examples as well. So by moving forward with Mahiba's question, what do you think are the homologous family, or is the homologous family which are unsaturated and happens addition polymerization as well? In which family? Yes, awesome. In which family unsaturated addition polymerization happens? It happens in alkenes, and in condensation polymerization can happen in the many other different compounds, which we will discuss later on. Please mute your mics. Raise your hand if you want to ask anything. I'll come back to you. Yes, I got many examples like alkenes. This alkene example is perfect for the addition polymerization. Is there any question so far, or the difference between addition and condensation polymerization is clear? Okay. Any questions? No questions. So let's move on. Okay, let's move on to the next one. This is the one. Great, crystal clear. I like it, crystal clear. Now you have two compounds over here. I will mark it. Now this one. Okay, great. So what I'll do is I'll mark it as an A, and I'll mark it as an B, so that you will be able to answer me in a more proper way. Identify the types of polymerization. The types of polymerization in this. Now here we have a compound. This is a monomer. So I can say that, I have 5 monomers. I need to combine these 5 monomers into a one big polymer or a macromolecule. Which polymerization will be suitable for this? Addition or condensation? Okay, what will you answer? Which polymerization will be applicable, and why?
Addition.
Why? And someone says both.
Addition to carbon double bonds.
Very good. Right answer. Addition polymerization. Amazing. All the answers are correct. Bingo. Addition polymerization, that's right. Here we have addition polymerization, and reason why this will undergo addition polymerization because of the double bond in between two carbons. Yes, Arisha, do you have a question? Yes, Arisha, do you have a question? You raise your hand.
Yeah. Miss, what should we write? What is preferable that
Miss, what should we write?
this compound is an alkene, or this
compound is an alkene, or this is an unsaturated compound?
Good question, indeed. Okay, if the question is asking that which family this compound belongs to, which family, so that means the question is strictly indicating about the name of the homologous family or series. If the question asks like this, then you will go with the answer of alkene. But if the question is asking about the name of the compound, preferably that which compound is this, then you will give the name, which is ethene. And another thing, if the question can definitely ask about the polymer of ethene as well. So if the question is asking about the name of the polymer formed because of ethene, what will be the name of that compound?
Polyethylene.
Awesome. Very good. Excellent girls. Excellent. So the name of the polymer formed because of ethene will be polyethylene. Okay, now what I'm doing is I'll be writing that how we're going to represent polyethylene, and you need to tell me if I write it correct or is there any mistake. So now this is ethene, this is ethene, this one is polyethylene. Do you feel that the structure of polyethylene is correct, or there is something missing?
Miss, there should be N outside the bracket.
Okay, it's there. Is it perfect now?
I can't see the N.
Is it perfect now?
I can't see the N.
Because that's missing. That's right, because this one is missing, N. This N is missing. If this N is not there, then your structure is not correct. Why? Because this N represents that this is a combination of number of molecules, and there can be a huge number of molecules together. So if this N is not there, then your answer will not be considered as correct. Okay, in one of the response I got that infinite number of molecules, which I assume that you are trying to say that there will be infinite number of monomers. So I want the responses from everyone. That is that correct? Will it be infinite number of monomers together? Infinite number of monomers joined together to form a polymer? Okay, it's one no. What else? No. Yeah, it won't be infinite number of monomers combining together. In polyethylene, for example, the monomers are in thousands, of course, but they are not infinite in number. They can be a big or huge number in which they are joined together, but the number will definitely be definite. Is there any question so far? Is there any question so far? Okay, great. So you were very sure about number A, which is done now. This number A it was very familiar to you. Now comes to number B. I need two responses about this. Number one, the name of this particular compound, what it will be, as it's a monomer, and what will be the name of this monomer's
Miss
polymer?
chloroethene and polychloroethene.
Miss chloroethene and polychloroethene.
Okay, great.
Polychloroethene.
Maiva, you can say this?
Polychloroethene.
Very good. Excellent. So this one is, yes, it does, we will call it chloroethene, correct? And the one which will be formed is polychloroethene, but there is a specific name we use for it, which is very common, for this particular one. There is one common name we use for it because of its a lot of uses. What that one is? Let me see the responses. The very common name. Okay, I got one response. The very common name. I'll draw the polymer of this compound as well. That will help you to identify. Okay, let me draw. That would be a kind of a hint, because that's how the MCQs comes. They can give you a structure and then multiple options to identify what is the correct name of this particular structure. Now this is the polymer of this monomer. So what do we call it? Yeah, awesome. Now I'm getting responses. So you identify correct. That's right. So that means you identified the polymer correct. Yes, this is PVC. PVC, which is polyvinyl chloride. Can you tell me the use of PVC? Where does it use for? Where do we use for? The use of the polyvinyl chloride. Where do we use it? Okay, making plastics, shopping bags, make raincoats, pipes. Great. That's right. Okay, great. Generally used for almost all kind of stuff where plastic is involved. That's right. That's right. So if you memorize the structure of a polymer, please do try to memorize the structure of the monomers as well, because that's again really important. Good job, girls. Good job. Highly appreciated. Moving on to the next one now. It says, which polymerization process occurs in this case? Ashmal, you raise your hand. Yes. Any question?
Miss, your voice is starting to cut out again.
Miss, your voice is starting to cut out again.
Okay, I'm so sorry about that. Is it clear now?
Yeah, it's better.
Is it clear now?
Yeah, it's better. Yes.
Thank you. Thank you. Okay, great. Which polymerization process occurs in case of this one? This one. Great. Yes, Bria.
Condensation polymerization.
Condensation polymerization.
Great. Okay, very good. If I talk about this dicarboxylic we have studied that condensation polymerization will, if condensation polymerization happens, it will release a water molecule. Okay, so if a water molecule will be released in the case of condensation polymerization, that means, yes, Raima?
Miss, I don't understand. Why is there a box in between?
Miss, I don't understand. Why is there a box in between? I don't get that.
This box represents the number of carbons in between these two functional groups. As we discussed in our previous class, that we do have functional groups, right? Now this one and this one on the sides, I would say, is 1 and it's 2. These are the functional groups. And these functional groups are attached with a couple of carbon numbers. There can be 5 carbons in between, there can be 6 carbons in between, anything. But we are not supposed to draw all of these carbons because it's not necessary. And why is that? Because any reaction of hydrocarbon or I would say organic compound is dependent on their functional group. So our purpose is to draw only the functional groups, because as I'll move on, you will see that these functional groups are involved in the particular reaction, not all of the carbons in the center. So to make it more simple and easier, we draw this box instead of writing all of the carbons in between. Is that clear?
So basically, this is a type of polymerization, right? It's just
this is a type of polymerization, right? It's just there to show the amount of carbons.
Number of carbons, that's right. It is just to show the number of carbons, but because we have nothing to do with those number of carbon atoms, so that is why we don't show them.
This isn't
we are
an
only
isomer,
dealing
right?
with the functional groups.
This isn't an isomer, right?
It is an isomer.
Okay.
This is.
But isomer will be a very different terminology. I would rather say that stick to monomer. It's a monomer. It's a monomer with 2 functional groups at the edge of the compound.
Okay, thank you.
Okay, thank you.
Great. Any more further question? So where were we? We were talking about that you have decided, all of you, that the kind of polymerization which will be happening over here is condensation polymerization. So if it's condensation polymerization, that means there will be a release of the water molecules. That means that we will get 1 hydrogen and 1 hydroxyl ion. Rama, you still want to say something, because I can see your hand raised. So we will definitely get 1 hydroxide and 1 hydrogen. Now the point is that which compound between these 2 compounds, which is A and a B, which one will give me a hydroxide and which one will give me a hydrogen. I'll ask for A first of all. What will I get from an A? Because it's a dicarboxylic acid. Shall I get an OH or an H?
Yes, hydroxide.
Hydroxide.
Yes,
OH.
Hydroxide.
Very good, very good. If I'm getting hydroxide from this compound, then automatically I'm getting what? I'm getting a hydrogen from this one. So they both will give us a water molecule. And the positions from where carbon and nitrogen free, they will join together to form a polymer. Is this clear, or you have any question?
Clear, miss.
Is it clear? Shall we move on?
Yes.
Is it clear?
Clear, miss.
Great.
Yes.
Awesome. Okay, so let's see what I get next. So before I move on, I want quickly, I want one of the student, Arisha, let's suppose. Arisha, what we have discussed so far, just give me a quick wrap up so that I can move on to the MCQs.
So we basically discussed what polymerization is.
So we basically
To sum up the process of polymerization, I would say that polymerization is joining large monomers together, and when these monomers join together, they form a polymer. Another name for polymer is a
Great.
macromolecule.
Another name for polymer
Awesome.
is a macromolecule.
Another name for polymer is Another name for
Great,
polymers.
great, great.
We studied the difference between natural polymer and synthetic polymers. Synthetic polymers are man-made, and natural polymers occur naturally. Then we discussed the type of polymerization, that is addition polymerization and condensation polymerization. Addition polymerization, in addition polymerization, we break the double covalent bond. That is, we break the unsaturated compounds, and in condensation polymerization, we break the saturated compounds. Yeah, that's it. Then we discuss some examples of addition polymerization and condensation glow.
Awesome, bingo. That should be a big clap for Arisha, but of course we cannot do it right now, but that is amazing. Anyone else from the people, now if you want to add something which Arisha or I missed, or if you want to correct something, or if you want to give a go ahead, that's completely up to you. Shall we, is it all we discussed today, or did we miss anything? So Kansa has given a clap to Arisha. Very well done. Yes, Asbia?
Miss, I've seen in some of the questions that when the polymerization question, that in some of the questions the boxes are filled. Like there are lines in some boxes, and on the other hand the other boxes are empty. So how can we differentiate between condensation and addition polymerization on the basis of this?
Okay. So addition polymerization and condensation polymerization, number one, SBI has nothing to do with the boxes in them. Okay, the condensation and addition polymerization will be differentiated, or it can be identified simply by the bonds between the carbons. If you see a double bond between two carbons, I repeat, it should be between two carbons specifically, because we have a lot of other elements as well, like we have hydrogen, we have oxygen sometimes, but the identification of having addition or condensation polymerization is whole and sole dependent upon the carbon-carbon double bond or a carbon-carbon single bond. So boxes have nothing to do with this. If a carbon-carbon double bond is there, then it will be an addition polymerization, and if it's a carbon-carbon single bond is there, then it will be a condensation polymerization. I hope this thing is clear to you now. Okay, since great, I got to go ahead, and there is nothing you want to ask about it. I'll move on to the MCQs, and these MCQs are the kind of examples which will be there in your virtual test. Also, this kind of a mixed thing which is there to for me to understand that how much you remember from the previous classes as well. So this is an MCQs from the past papers, which is, so it says, alkanes are saturated compounds containing carbon and hydrogen only. Structure 1, 2, 3, and 4 are saturated hydrocarbons. Now the question is, which pair of structures are isomers together? A, B, C, or D? Which one is your choice and why? Okay, I'm waiting for the responses. I hope you all can see, and you can share your responses with me. And if you do not understand, it's perfectly alright. I'll help you out. Okay, I got an A, a lot of A's, but I did not get the reason why. Why it's an A? Okay, one reason I got is that they have same carbon atoms and hydrogens. Same number of carbon and hydrogens. Bingo! Excellent. Yes, Mahiba, you have raised your hand.
Same number of carbon atoms and hydrogen atoms.
Very good. How you can identify an isomer? An isomer can be identified by having same carbon and hydrogen atoms, the number of carbon and hydrogen atoms in a structure. So if it's an A, let me cross check if you people are right or wrong. So there are 1, 2, 3, 4, 5, 6 carbons. It has 6 carbons, and hydrogens are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. It has 14 hydrogens. Let me count the other one. In A, it says it should be number 2. So 1, 2, 3, 4, 5, 6. It has 6 carbons, and hydrogens are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. It has 14 hydrogens and 6 carbons. In this case, 1, 2, 3, 4, 5, 6 carbons, but not 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 hydrogens, so it was not a possibility. 1, 2, 3, 4, 5, 6 carbons, sorry, 6, no, 7. It has 7 carbons, and obviously was not a possibility. Here there was a difference of hydrogen atoms, and here it was a difference of carbon atoms, but here they have all equal number of carbons and equal number of hydrogens. That is why they are isomers to each other. Very good going, girls, very good. It's impressive. Moving on to the next one very quickly. So there we go. It's number 34, and it says, when butene react with bromine, which compound could be made? When butene is reacting with bromine, which compound could be made? It's related to alkene family. What according to you is the right answer option from A, B, C, and D, and why? Okay, it's a B. It's a B from the people. B, 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 B. Double bond broken down. B, 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 B. May I know why? Why is also part of my question.
Yes, because when it's double bond, when the double bonds were broken, the bromine
was attached with both the carbons.
Okay, awesome, amazing. Amazing. So when we say butene, we clearly mean that there must be 1, 2, 3, 4 hydrogens. Am I right? There would be 4 hydrogens for sure. And when it says butene, that means there will be 2. There must be a double bond over there as well. The rest, all of them definitely would be hydrogens. And here we all have hydrogens, and when bromine, it is reacted with bromine, bromine must have broken down this double bond. And in this double bond, these hydrogens. Okay, let me see what's coming up. 4 carbons, sorry, my bad. It's good to know if students are correcting me. So we have 4 carbons, and with these 4 carbons, different hydrogens are attached. And there is a double bond between one of the 2 carbon because it's a butene. Please do correct me if I say something wrong. Now bromine, when it is reacted with, so the double bond will definitely be broken down. When double bond is broken down, then that means that 2 bromines are attached with the carbon. 2 bromines. So 1, 2, 3, 4, 1, 2, 3, 4. If I say in all of these, 2 bromines are attached. See here, 2 bromines are attached, 2 bromines are attached, 2 bromines are attached. What made you give me the answer which says a B? That can be an A, there can be a C, that can be a D as well. Okay, great. Position. Awesome, girls. Awesome. Amazing. So I can see raised hands. Sarah.
Because of the position of
Sarah,
that
please.
is the exact place where
Because
the
of
double
the
bond
position of
that is the exact place where the double bond would be.
What's wrong with position A? What's wrong with A?
I'm sorry, I'm unable to identify.
It's perfectly alright because your first answer is so super amazing that it's perfectly alright. You can see this structure in front of you. Anybody can answer me that what's wrong with this position?
Miss,
so this is the structure.
Single carbon only, like there was double bond between 2 consecutive carbons.
Amazing. Amazing. So what's wrong with position? Sarah wants to say something. Yes, Sarah again. Sarah, you want to say something? Okay, bingo, that was right. Here, what's wrong with the position? The position is wrong because these two bromines are with this same carbon, which is not possible. Here, this bromine is with this carbon and then with this carbon, which is not possible. Here, again, they are very two different carbons and they have a huge distance between them. If we see this is structure in front of you, this one is structure, these bromines should be with two adjacent carbons, because here if this double bond will be broken down, then one position will be open over here and the other position will be open over here. So there should be two bromines attaching with two adjacent carbons. That is why we went for B, and that's how we justify the position thing. Is that clear to everyone? Is that clear to everyone, or any question? Amazing. Great, amazing, awesome. Now quickly move on to number 5. Which statement about the propene is correct? Which statement about the propene is correct? Yes, Priya.
Can you zoom it?
Yeah, I did it. Is it visible to you now?
Yes.
Yes.
Okay, which statement about propene is correct? Give me the answers and with the reasons as well, please, everybody. D. No D, it's an A. D. Okay. Dehydrogenation. Okay. Alex, try. Mahiba, you want to say something?
Sorry for it.
It says which statement about...
Sorry,
Sorry?
it was mistake. Sorry.
Which statement about propene is correct? Propene is correct. Keeping propene in your mind. It can be formed by cracking butane. It has a formula C3H8. It is a saturated hydrocarbon. It reacts with hydrogen to form methane. So let me see what are the options. So quickly join back. It's amazing. It's an A. So for a lot of students, it's an A. Let's see. Okay, great. It's an A. Please, I'll be very grateful if you can share the reason with me. Why do you think it's an A? Why?
Miss, in D, ethane is forming, whereas it should...
Miss, in D, ethane is forming, whereas it should
B is wrong because 3 2s is 6 and it is not a sound,
because
of course,
3 2s is 6 and it is not a sound, of course, so A is left.
Okay, great. Anyone else wants to chip in? Okay, great. And yes, that's a good clarification. So by cracking butane, propene and methane can be formed. Great. Butane is a greater than propene. Amazing. That's right. Alicia says I should explain this. I would love to explain this. So Arisha, yes, Hajra, you want to say something?
I think the answer is A because C4H10 is... The answer is A because C4H10 is...
Okay, C4H10 is butane, which is a bigger compound. So let me take the question. Alicia, specifically and precisely for you. See, buddy, if you are saying, if we will see that which is not the possibility. First of all, it reacts with hydrogen to form methane. You need to know, to get this answer correct, that what exactly propene is. Propene is a compound of 3 carbons with a double bond in between them. And also there will be hydrogens attached to it. There will be hydrogen attached to it. Sorry about that. Okay. Like this. Correct me, girls, if I'm wrong somewhere. So yeah, this is the structure of propene. You need to understand the structures for getting any answer correct. It reacts with hydrogen atom to form ethane. This cannot be a possibility because if it will react with hydrogen, the hydrogen will break down as it happens in bromine previously, and 2 hydrogens will be attached over here and it will never end up as ethane. Instead, it will end up as propane. One thing. Alicia, stay with me and unmute your mic and tell me if you get this or not.
Yes, I get it.
Yes, miss, I get it.
Great. Okay. Moving on to the next one. It is a saturated hydrocarbon. It cannot be a saturated hydrocarbon because we studied already that saturated hydrocarbon means a carbon-carbon single covalent bond, which is not there. It has a double covalent bond, so it's not a possibility. Did you understand this?
Yes, miss.
Great. Now moving on to this option which says C3H8. Now count. See, 1, 2, 3, 1, 2, 3 carbons are there, but 1, 2, 3, 4, 5, 6 hydrogens are there. So the correct formula is C3H6. So this cannot be an option as well. Now, number one, these three, we got the logics. They are easy to crack that this is not a possibility. That is why A is the right option. Number one. Number two, butane is a larger molecule. If we will break down butane, then we can get propene from there. Why? Because when we say butane, we say 4 carbons. So these 4 carbons can broken down into 1 methane and a propene as well. In 1 methane with 1 carbon and propene as well. Alisha, is it clear to you now, Bacha?
Yes, miss, it's clear. Thank you.
Yes, miss, it's clear.
Thank you. Thank you so much. Moving on to the next one. And this is the last one for the day. So let's see who will get it right. Bria, you want to ask or say something? Please go ahead.
Polyester.
Achha, you have already cracked the answer to the next one. Okay, let's see. Let's see what the other people have to say about it. Okay. Which term describes the structure of trilene? Polyalkane, polyamide, polyester, or protein? Which one will be the correct answer? The last one for the day. Okay, it's a C. For Asbia also was a B. Okay, great. Let's ask from the person who very enthusiastically get it right and share the answer. So Bria, would you like to answer this question, because most of the people are unable to understand it?
Polyalkene is addition.
Yes, Asbia.
And polyamide is for nylon and protein.
And polyamide is for nylon and protein.
I'm sorry, Bria. I think your voice is not clear. Can you please come again?
Protein
okay,
is not
girls. It's alright. I guess Bria has some.
Protein is not a. It doesn't describe it.
It's protein.
Okay. Okay, great. Good one, by the way. Anyways, Asbia you wanted to say something? Please go ahead.
First.
Miss, it was me who told first.
Okay.
Okay,
okay,
so
my bad.
again,
Please
as
go ahead.
Bria said for A, B, I'll explain part B.
Okay, so
Protein
again, as
is
Bria
a
said for A, B, I'll explain part D. Protein is a natural
polymerization. So trilene is due to condensation polymerization.
So trilene is due to condensation polymerization where a water molecule is released. So that's why trilene is polyester.
That was superb. Superb. That was superb. Yeah, right. Bingo. Yeah, that's my favorite word, which is called bingo. Well, that's right. I'll try to explain it more further. So, number one, girls. Number one. Okay. Can you hear me now? Can you hear me now? Bingo one was the awesome one. Yes. So now this is trilene. Number one, which term describes the structure trilene best? So when trilene comes in my mind, initially I told you very initially when we were doing synthetic and natural polymers that you need to memorize the list, because this list will help you out to identify that exactly which one is a natural polymer and which one is a synthetic polymer. When it comes to trilene, trilene is a synthetic polymer, number one. And also, Asbia was really right that trilene forms with the help of condensation polymerization. Alright, when it happens to condensation polymerization, number one, because it's a synthetic polymer, so protein cannot be a possibility. And polyalkenes also cannot be a possibility, because alkene family, it always indicates to the addition polymerization. So if an alkene is there, that means addition polymerization is happening. So it cannot give us a compound which is a result of condensation polymerization. When it comes to polyamide, polyamide means it is referring towards nylon, or it is also referring towards the amide linkage. And this amide linkage can be connected to the protein as well. So it rather can be a nylon, or it rather can be a protein as well. So the best option, we are left with a C. Sometimes what happens is, sometimes exactly you don't know what is the right answer, but you try to figure out that which answer is not exactly a possibility. If you see me doing the previous one, I did the same thing. I didn't know the right answer, but I tried to find out the possibilities. Will this be a possibility? Will this be a possibility? They had such keywords which were directly telling me that these cannot be a possibility. So I got to the right answer. So I had two links. One was the synthetic polymer and the other one was the condensation polymerization. So I quickly knew that alkene cannot be a possibility, natural cannot be a possibility, and when amide is linked to the protein, so if it's conditional, that cannot be a possibility as well. So that's how we get the right answer, and which was a polyester. Is this clear to you, the ones who were asking that the thing was not clear? Is this clear to you now? Yeah, Raima. Okay, good, great. Awesome. You people have done an amazing job today, and I feel that the classes which we had conducted previously, that really helped you out and helped me to make myself feel very happy and special about the fact that you people are doing good. So great. So take care of yourself. Inshallah ta'ala, I'll see you in the next class with another new topic and some more MCQs. Bye everyone. Take care.